Okay, so factoring. Back in the 9th grade, you were supposed to learn how to factor quadratics. And in factoring quadratics, you really need to go back and refresh how to factor in general. When we factor in general, we are dividing out a common factor. We call this common factor that we were trying to factor out the greatest common factor. You've been doing this for years. Quadratic equations can be solved by factoring, just like we could solve them by graphing. And we're going to use the problems below to refresh our factoring skills. Now, in factoring, we want to factor out the greatest common factor of an expression. The greatest common factor is the greatest number that is a factor of both or more terms. So here we have two terms. Here we have two terms. Here we have three terms. Three terms. We want to find the factor that is the greatest factor common to all the parts. Now, we want to first look at the numerical parts, 12 and 18. And we want to find the greatest common factor. Your calculator will do this for you when it comes to numbers, not variables, but numbers. So if you want to get a calculator, do that. I'll pause the video for just a minute so we can get situated. Alright, so having used our calculator, and again, we did math, num, we went down to GCD, pressed enter, plugged in 12, comma, the comma is above the 7, just above the 7, 18, and then enter, and it gave us 6 for our GCD, which is the same as GCF, greatest common factor, greatest common divisor, mean the same thing. And so 6 is the numerical greatest common factor. Now, there's also a variable in this problem. So we have to also ask ourselves, is there a GCF of the variables? There would only be a GCF of the variables if you have a variable in all the locations, that type of variable. So there's not a K here, right? So K is not part of the GCF. So the only part of GCF here is 6. Alright, now let's go to number 2. Now, in number 2, we do have some variables in both places, the same type of variables. We've got an X here, we've got a Y here. So let's first find the GCF of 40 and 64. Again, your calculator will not find the GCF of variables, only numerical values. So again, since we've already got GCD on the screen, can y'all see that on there? You've already got GCD. Just scroll up to GCD till it's highlighted, press enter, and then change the numbers. So 40, 64, press enter. 8. So our greatest common factor of the numerical values is 8. Now, we still have to deal with the variables. It's real easy. The greatest common factor of variable expressions is the highest exponent, is the lowest exponent of those variables. Because we want the greatest thing that's in common, right? Well, does this 4, does it have x to the 4th, does it have 8? No, it's only got x to the 4th, so it can't have 8. So you take the lowest variable, the lowest exponent of that. So this would be x to the 4th. Alright, and you're going to do the same thing for the y's. The highest exponent is 1, but that's the same for both of them, so we're going to take y. Just y. 8x to the 4th, y.
I can do this right here. I can do this all day.
And that's it. Alright. Finding the greatest common factor is an important piece to being able to factor in general. Okay, let's do number 3. Alright, on number 3, you got 3 different numbers. We can't put 3 different numbers in the calculator, but we can do 2 at a time. So, we can do 14 and 35 and press enter, and that is 7. Now we do it again with 7 and 7, but that would just be 7. So we don't really need to do it. I'm going to do it anyway. 7 and 7, and that's 7. So 7 is the GCF of the numerical part. Now we look at our variables. We've got the same type of variable in each term, and we want to take the lowest exponent, m squared. That's it. That's the GCF. Alright, number 4. 3, 5, and 8. Now, do 3, 5, and 8 have a greatest common factor? There's no common factor other than 1. and you don't count 1, so there's nothing you can do with those numbers. Is there a GCF of the variables? All right, yes, because you have A's and B's in all 3 places. So A squared, A. So what would that be? A, just the lowest exponent, A. And then the B's, B squared, B, and B. So that would just be B. So the GCF is AB. So you have to be able to find the GCF of the numerical part and the variable parts. So when factoring, always look for a, what do we want to put there? Always look for a GCF first, okay? So we're always looking for the GCF no matter what we're factoring. There may not be a GCF, but we're always going to look for it first, okay? Especially if we're dealing with trinomials that might have a number in front, like number 12, a number in front of the squared term, or like number 11, okay? We're certainly looking for GCF in those. If it doesn't have a number in front, if there's not another number other than 1, there's not going to be a GCF between the numerical parts. All right, so now we're moving toward trinomials. So when we are factoring trinomials, like ax squared plus bx plus c, this is your standard form of a quadratic, where a is equal to 1 to start with, it's going to make it simpler for us to factor. What we're going to do is we're going to immediately break this thing into 2 sets of parentheses. You can go ahead and do that for all of them. I don't know if you remember doing this from 9th grade, but I'm not going to do it on the last 2 because we got to factor out a GCF first. We'll do that later. All right, so we're looking at 5 through 10. All of these are going to be done the same way. This is by basically trial and error. This is the way I've found that over the years the best way to do it. There are other ways to do it. Understand that. But to me, having been a teacher, having been a student myself, this is the best way to do it. Now, basically what you're doing is you're defoiling. Y'all remember the FOIL method? First, outside, inside, last? We're basically undoing that. So, I'm going to look at the first term here, and I'm basically going to factor it. So, the only way to factor x squared is to be x and x, correct? So, I'm going to put x's in the first place of the parentheses. So, you would do that for all of these. So, go ahead and do it. WW, CC, NN, AA, NN. This process of like working all the problems one step at a time is called chunking. Chunking, where we're basically taking this little chunk and doing it for all problems, do the next chunk, all right, whatever. Now, the next step is to determine signs. And to determine signs, you start with the last sign. So I look at the last sign and it's positive. Anytime the last sign is positive, it tells you you're going to be using the same sign. The signs may not both be positive. They might both be negative. But in this case, they're going to be the same, but they are going to be the same. So we know we're going to have the same sign because of the last term being positive. We know that those 2 signs are both going to be positive because the middle term is positive. So it's going to be plus, plus. Okay? So what steps do? We first factor x squared into x and x. Step 2, deal with signs. Step 3, take factors of last term that add to middle term. Hold on just a second. Hello? Hey, how are you, Jasmine? Good. We're taking the factors of the last term that add up to the middle term. The factors of the last term that add up to the middle term. So, let's go ahead and do the signs for the rest of these, and then we'll come back and do the factors of the last term. So what would the signs of this one be?
Negative and positive?
Well, the last sign's positive, so that means they're the same. Negative, negative. Okay, what about this one? Now, if the last sign is negative, you're going to have negative, positive, or positive, negative. It doesn't matter which order. I generally do positive first, but it doesn't matter. So here again, look, the last sign's negative. Positive, negative. I'll explain why in just a minute. Okay? Look right here. Look right here. Positive. Positive. What does that tell you? They're the same. And the middle term's positive, right? So the only way, we have to have two positives. All right, look at this one. Positive is the last sign, so they're the same, but they're going to be negative, negative because the middle term is negative. Now, let me explain why that is. Okay, what is the only, let me back up. There are two ways to get a positive when you're multiplying. You can multiply positive times a positive and get a positive, right? Or you can multiply negative times a negative and get a positive. That's what this is saying. This is saying negative times negative is positive. But negative plus negative is negative. Alright, look down here. We've got a negative sign that's last. The only way to get a negative is to do a positive times a negative, right? So our signs have to be different. But depending on the middle sign is determined by whichever of those is the largest. So if I'm doing a positive 5 plus a negative 3, it's going to be a positive 2, right? 5 minus 3 is 2. But if I did negative 5 plus positive 3, it would be negative 2. So whichever of those factors is the largest, that's the sign that goes to the middle. So look at the last rule. Take the factors of the last term that add up to the middle term. So let's do that. Factors of 45. Let's list them. 45 and 1. 15 and 3. 9 and 5. Are there any others? Are there any other ones? I don't think so. It's not divisible by 2, right? It's not divisible by 4. It's not divisible by 6, 7, 8, but it is divisible by 9. We're done. These are the 6 factors of 45. Now, of these factors, which pair of these adds up to 14? 9 and 5. So that's the pair that I choose. Now, does it matter where I put the 9 or the 5 right here? It does not. It does not. Okay? So, this is x plus 9 times x plus 5. And look what happens if we FOIL this out. First will be x squared. Plus 5 times x is 5x. Plus 9 times x, 9x. Plus 9 times 5, 45. And what's 5x plus 9x? 14x. Isn't that what we had here?
Yep.
Yes. So we are correct. You can always check yourself by FOILing it. So that's how we do it. So let's look at this one. What factors of 45 take the factors of the last term that add up to the middle term? So what factors of 45 add up to 14? 9 and 5. Okay? Alright, let's do this one. 26. Let's list the factors. 1 and 26. 2 and 13. Are there any other factors? 3's not, 4's not, 5's not, 6 not, 7 not, 8 not. No, this is it. So, which of these factors combine to give you negative 15? Now, understand, both of these are negative, right? Both of these are negative. So, negative 2 plus negative 13 gives you negative 15. So, that's the pair that works. Okay, let's look at 7, because it's a little different, because now we've got a negative at the end. But let's go ahead and list the factors. 1 and 48. 2 and 24. I generally start with 1 and work my way down. 3 and 16. 4 and 12. 5 is not. 6 and 8. And once you get to the factors that are almost the same, or very close together, there aren't any more. Okay, so, which pair of these factors, if I were to add them together, gives me a positive 2? 8 and 6. Now, you say, wait a second, 8 plus 6 doesn't give you positive 2. If one of them's positive and one of them's negative, it does. So, anytime the last term is negative, you can think of these as the difference. Which pair is the difference of the middle one? So, 8 minus 6 is 2. So which one needs to be positive, which one needs to be negative? Good. Excellent. That's that. 8 minus 6 is 2, and 8 times negative 6 is negative 48. We did it. Alright, let's look at this one. Factors of 72. 1 and 72. 2 and 36. 3 and 24. 4 and, let's see, 72 divided by 4 is 18. 4, 18. 5 is not. 6 and 12. 7 is not. 8 and 9. And that's it. Okay? I know that's it because 8 and 9 are almost the same. By 1. Alright, so we want a negative 1 in the middle. So which of these have a difference of 1 if 8 and 9? So put the 9 where? Put it at the end because you want to end up with a negative 1 when you add them, right? So 8 plus negative 9 is negative 1. We're done. We did it. And 8 times negative 9 is negative 72. Alright, let's look at number 9. This is easy, okay? Because anytime they're both the same, you just look for how they combine. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6, and we're done. Alright, so the pair that adds up to 12. You're done. Very simple. Alright, let's do the next one. Okay, there are only 2 factors of 1, guys. It's just 1 and 1. There's no other way around it. There's only 1 factor of 1, I should say. So that one's done. Now, these next ones, you have to first factor out a GCF. Because notice there's a number in front of the square term. So what is the GCF of 2, 16, and 40? 2. So 2 gets factored out, and what's left? K squared minus 8K minus 20. You can't just forget about what's left over. That's the main part. The part that's left over is what you get when you divide out the 2. So 2K squared divided by 2 is 2K. Negative 16K divided by 2 is negative 8K. Negative 40 divided by 2 is negative 20.
That all makes sense.
Okay? So now, we're going to bring down the 2. It just gets carried along for the ride. Okay, what goes in the first place? K. What are my signs?
Plus, minus.
Good. And then factors of 20. 1 and 20, 2 and 10, 4 and 5. Which pair of those, and I don't want to do 16, I want to do 8. Which pair of these are 8 apart? 2 and 10. So where does the 2 need to go and where does the 10 need to go? 2 in the positive, 10 in the negative, and you're done. That's it. Alright. This one also has a GCF. GCF is 5. Factor it out. What's left when I divide out the 5? Do it.
Z squared minus 5Z minus 6.
Good. Plus 6. Alright, good. Alright, now 5 and then 2 sets of parentheses. Okay, what goes first? Z and Z. What are my signs?
Plus and minus.
Well, the last sign is positive. You always look at the last sign. But they're negative in the middle, so both negative. Okay, now I want the factors of 6, so 1 and 6, 2 and 3. Which pair of those adds up to 5? 2 and 3. And I'm done. Now, here's the thing, guys. This is when you're determining which factors to choose. If the last sign of your problem is positive, then you're looking for the factors that add together because both signs are the same. You're just adding them. If the last sign is negative, you're looking for the factors that when you subtract them, you get the middle term. But a subtraction is just addition of negatives. So it's really all addition. Okay, now, we're going to go over to some practice for this. Go over to homework 1. And let's turn it to the back of homework 1.
The back?
Yeah. Okay, you are going to do 7, 8, 9, and 10 right now. Do those right now. And I'm going to pause the video. Okay, so the answer to this, x squared plus 10x plus 24, your two sets of parentheses. Your signs should both be positive, x plus and x plus. And then the factors of 24. Guys, y'all listen up, please. Factors of 24 that add up to 10, 4 and 6. So there it is. All right, for the next one, n and n.
And plus minus.
Plus minus. So 1 and 85. 2 is not. Is 3 a factor? No. 5 and 17. And anything else?
That's it.
So that's it. Okay. 17, 5. Good. All right, number 9. We've got a GCF. So what's a GCF of 6, 24, and 24? 6. Factor that out. That leaves p squared minus 6p plus, 4p plus 4. And then when we factor, we get p and p. What are my signs? Negative, negative, and then 2 and 2. All right, good. All right, number 10. GCF is 3. That leaves a squared minus 1a minus 12. 3, parentheses, parentheses, a and a. All right, so what are my signs? Positive and negative. What are the factors of 12 that are 1 unit apart? 3 positive, 4 negative. That's it. You're done. Good. Very good.